welcome to another episode of Read All About It. I'm your host, Reed. Today I've got part two of the compare and contrast, 6 years of archery technology and kind of what do you get. Originally, today's video was going to be getting them outside, shooting them against one another, and redoing the speed test because I found that the RX-3 with the older strings, they had stretched a little bit, so it was slightly out of spec, not pulling 80 pounds. Not drastically under, but it was like 78.4 or something like that originally. So we twisted up the cables a little bit and ended up having to do a little bit of tuning on it. And then on the RX-9, I hadn't done any tuning on that yet. And so I shot that through paper as well, and had a pretty terrible tear. So I ended up having to tune the RX-9 as well. And so today's video kind of changed from, just shooting them against one another outside, seeing what downrange velocities were and things like that with the lab radar, to more of a tuning between the two models and how things have changed and progressed over those last 6 years, and what you have to do for each model to get them to shoot through paper and tear a bullet hole. So I also, being a DIY guy, I haven't really invested in permanent bench mounted tools for a lot of things. I used a Synonym bow press, a portable bow press. That's what I take with me in my deck drawers on hunts and everything, so that if something goes awry and I need a bow press, I have one that works on almost every single model of bow, and can get me back up and running. And then I have this bow vise, which is a Cane DL, so www.canedl.de. So it's a German made bow vise. You have this little adapter that screws into your stabilizer mount, and that's how you mount it to the vise itself. So you can, spin it around, and then there's this ball head here that allows you to manipulate the bow around in whatever fashion you need to be able to work on your bow. As you'll see in the video, between the press and the vise, and then my homemade draw board, which is a worm gear boat trailer winch mounted to a 2x4, and then some pipe fittings, so a flange, and then a cap and a piece of pipe that I've wrapped in a washcloth and duct taped on there just to protect the finish of my bows. So between those simple tools, I'm able to do everything myself at home for not a ton of investment. All in, I've probably got $350, $400 maybe invested in the tools. I'd have to go and look and see what they retail for now. But I know I went budget option on all those things, but it allows me to work on all my own stuff. This was the first time I had ever played with shims, which is how you adjust the RX-9. And it was a little bit of a challenge to make it work with the tools that I have. But ultimately we did get it to work. Took a little bit of ingenuity in redneck engineering on my part, but we didn't damage anything, and we're able to get everything shooting as it should. And then with the RX-3, the main issue there was cam timing, so we had to play with the twists in the strings to be able to get it to time properly after we shortened those cables a little bit to increase that draw weight poundage. But now they are both pulling in that 80-pound range, so we should be able to get a more apples to apples comparison when we do shoot over the chronograph again. But yeah, we took a little bit of doing. It was a longer process than I was anticipating for that day. I was just anticipating twisting up the cables on the RX-3 a little bit and increasing that poundage, and then getting to shooting, and then comparing a couple other specs on the bows. But that's why it ultimately changed today's video, because after I got into things, it required a little bit more in-depth tuning, and thought I'd bring you guys along with on that. So today's video is, the differences between tunings from 6 years ago to now. The Hoyt system is what the Hoyt system is. Now it's shimming the cam left and right. On this, for left and right tears, primarily we yoke tuned. So you have this split yoke cable, and you would lengthen and shorten your yoke there to change that cam lean ever so slightly to be able to adjust your left and right tears to some degree, as well as manipulating the rest. And ultimately you could shim the cam over with different size spacers as well if need be. But with the RX-3, it was relatively good out of the box for me. Just took a little bit of yoke tuning when I put new strings on. Ever since I put the new strings on, though, it has stayed in time and in tune, even though we've decreased our draw weight a little bit over a couple years worth of shooting with these strings. Those strings seem to stretch at the relatively same rate, so we were never, even now when I put it on the draw board initially, we were still in time, and shooting it through paper, our tear was still good. So, testament to Hoyt's durability and things. Nothing really moved, even with the strings stretching a little bit. And then I expect the same out of the RX-9 now that I swapped the shims left and right to correct a drastic knock right tear on the top and bottom. Now we are set at 0 on our rest at 13/16 and shooting a pretty much perfect bullet hole with the arrows. So that's all good to see, and wanted to bring that to you guys so that you could see the differences between 6 years of archery engineering and what those tuning systems do. Now, a lot of manufacturers have incorporated easier tuning methods than shimming the cam and having to take the axle out. That was the primary way that most manufacturers kind of did it over the last half decade or so, was with shims, shifting that cam left and right to correct for those left and right tears. And then Bowtech and Elite started coming out with different ways to manipulate either the limb or the cam left and right on a screw. And then in this last year, Matthews came out with their system as well, which is similar but different to the Bowtech system. And then Hoyt, it has stuck with their bulletproof system of the shims, albeit it's not as user friendly to be able to do yourself. But as you can see in this video, I did manage to do it with pretty basic tools. Didn't blow anything up, and everything, corrected by with the simple tools that I have here. So you don't have to go to a dealer to get things fixed. My closest dealer is about an hour away. So being able to do the things myself is advantageous. But, disclaimer, if you aren't comfortable doing these things yourself, don't know what you're doing, just take it to your dealer. Don't void your warranty and break things or anything like that by trying to do everything yourself if you're not qualified to do so. Yeah, without further ado, let's kind of get into today's video. All right, so I've got the RX-3 on my vise here. We're going to take an axle-to-axle measurement and brace height measurement. This is before I've done any adjusting or anything like that. Check the draw weight just to see how much those strings have settled over time. So we're going to go from inside of the axle to the outside of the axle. And yeah, we're measuring 30 3/4 of an inch. So we are a 1/2 inch long on, or 1/4 inch long on our axle to axle. And that equates to an 1/8 inch long on the brace height. So we are a little bit out of spec there, so we'll probably need to twist up the cables just a little bit to increase that draw weight, shorten that axle to axle length, and bring this back into spec. And we'll see if that translates to narrowing that discrepancy in speed between the RX-9 and the RX-3, as they were both advertised at the same IBO. So let's swap over to the RX-9 and see what that specs out at. All right, we've got the RX-9 in the vise now. This spec is supposed to be 30.5 axle to axle and then 6 1/8 brace height. So the RX-3 was 30.5 axle to axle with a 6-inch brace height. So we'll see if this is on here. Again, going to go from inside of the axle to outside of the axle. And we're about a 1/16 inch long on axle to axle measurement. So we're 30 9/16 on our axle to axle measurement. And then on our brace height to the back of the string, it looks like we're just right about dead on there at 6 1/8. So I would say this is within spec. Now we'll get the draw board up here, get the scale on it, and we'll see. This limb bolts are maxed out on both of them. We'll see what each one's drawing and go from there. If we need to adjust the RX-3, we will. I'll be curious to see if it is drawing actually 80 pounds, but we'll go from there. Okay, I've got the RX-3 in the draw board here with the scale on it. Going to measure draw length, loadout point, and draw weight, just to see what we're at before we make any adjustments. So peak weight I just registered was 79.4, then we fell off to 78, 77. We're on the stops. So let's measure loadout point here. Actually, probably want to do it this way. I would call that 32 3/4. And then draw length. It's actually quite short. Appears to be about 28 inches, which is odd because we're in the E hole on everything, and the E should be 29.0. So let's swap out the RX-3 for the RX-9 here. Okay, we've got the RX-9 in the draw board. Gonna draw it and see what the specs are here. Oh, I was gonna say it was reading 35, but that is kilograms. There it is. 80.5. Timing appears good. Let's see, loadout. On this, call it 32 3/4 as well. Draw length. It's reading out the same. So from the string to the center of the burger hole, which is in line with the throat of the grip, and we're in that 28 ballpark. I don't know if I'm measuring that wrong, but it seems odd. So I just learned something interesting. I'd never actually taken a draw length spec on any of my bows. I just, set them at what was comfortable for me using the modules. And, according to the stickers and everything, it read 29 inches. So what that actually equates to and how the measurement is taken for an industry standard is from the knocking point on the string, so the string to the deepest part and pivot point on the grip. So in my case, when I measured that, it was actually about 27.5. And then you add 1 3/4 inches for whatever reason, rather than just, giving us the actual spec. But so if we add 1 3/4 inches to that 27.5 that both bows were measuring out to the center of the burger hole, which is in line with the throat of the grip, that would bring us to that 29.25 inch draw length, which is kind of standard, I think, on the Hoyts, that they run about 1/4 inch long, from my understanding and what I've seen. So yeah, for whatever reason, that's the industry standard. So if you're a 29-inch draw length, you're actually drawing, the stroke is only like 27.5. So the more you know, I guess. So on to the rest of the testing, or actually we're going to bring the RX-3 up to spec. So we're going to add a couple twists to both the cables here and hopefully not affect the timing too much. So we'll do that, and then we'll throw it back on the drawboard and get those measurements again. I also wanted to give credit where it's due, because I didn't do the research, or I didn't know on that draw length spec. I was watching one of George Riles's recent videos on the Last Chance Archery YouTube page, when I was trying to figure out why I was getting a funky reading and what that equated to, and he laid that out pretty well in his recent video on taking an accurate draw length measurement on the Last Chance Archery 2.0 drawboard. So he walked us through that. So thanks to George, he knows his stuff. So on to the next. Okay, so I've got my bow pressed here. So I only have this little portable bow press. It is the Synonym bow press. It works for my needs. It's by no means the fastest press in the world. So if you're pressing and unpressing and doing a lot of different stuff, it's pretty slow, but it gets the job done when you're just doing it yourself. It's also super packable. You can take it with you on a hunt if you're going out of state or whatever. Spend a lot of time and money getting to a place just to have a peep pop out or something happen where you need to press your bow. It's a simple and effective way that a guy can get that done. If you derail a string, whatever. But we're going to twist some things up here. Oh, shoot. I need to slide that over slightly so I can, or actually I can do it this way. Get a little more slack. So all it is a block and tackle, essentially. So you've got a series of pulleys here, and it relieves the pressure on all your strings. So we're taking this yoke cable off, and we're going to add a half twist on each side here. There's that. And then this control cable, which is kind of tough to access here. Actually, we'll just take it off from up top here. Twist it up here. So one full twist there. All right. And now make sure everything is in its respective track before we let the tension off the press. Okay. Now let's take a quick axle to axle measurement and draw length measurement. So inside to outside here. We got a little bit more to go there to bring it back into spec. We're still a touch long there. We'll do one more twist on each and see where that gets us. Okay, and a half twist on each of these. And make sure everything is where it needs to be. And put tension back on the string. And take a measurement. Yeah, we're about 1/8 of an inch out of spec now. And about a 1/16 there. Let's put it on the draw board here quick and see what that yielded us for an increase in draw weight. So I read 80.7 there. So we're pretty much in spec. And then your drill dies while you are mid-draw cycle. Let's swap out a battery on this. All right, we got a fresh battery in the drill. So I do want to check the timing, make sure I didn't affect the timing by adding those twists. So our bottom cam is hitting, and our top cam is about a 1/4 inch from the draw stop. So we have to slow down the rotation of the bottom cam and speed up the rotation of the top cam. And so we manipulate that by, if we lengthen this yoke cable, okay, so if we take those half twists out of that bottom, that might get us closer, or add a twist to the control cable. That will also speed up this top cam. So we'll do that here because we need everything to be in time. As well as inspect. So, and here's where having nicer tools like a bench mounted boat press, last chance boat press or something like that, where you gain those efficiencies and time savings. But like I said, as a DIY guy who doesn't do this all that often, having the mobility of the synonym was the trade-off that I was willing to take. Let's see. Let's lengthen this rather than putting a twist in. So there we go. Do the same on this side here, which makes sense because I was putting twists and things into a pretty short string here, so it would make sense that that had a greater impact because the length of this cable on this split there is pretty short, so a twist on that makes a bigger impact than a twist on a 29-30 inch string. So let's take the press off and put it back in the drawboard and see what we got for timing. Not any better. All right. I actually did that backwards because that made it a little slightly worse. So I actually needed to shorten this by adding another twist to it. To get that in spec. So I haven't done it in a long time, so I couldn't remember exactly, but trial and error, and you can figure it out. If it moved it the wrong direction, just remember what you did, undo it, and then go in the other direction. So it's not super difficult to work on your own equipment. Trial and error, be safe. You have to have a basic understanding of how things work, but it is not overly complicated to do yourself. I'm pretty much self-taught. On these things. So we had taken twists out down here. Need to put those back in, plus some. And take one out up here. We'll see what that does. Okay. Everything is where it ought to be. Always want to make sure you do that. Make sure everything is in its string track and everything before you go and draw it, because that's a simple mistake to make that can cost you a new set of strings, or maybe new cams, or lots of different things that could go wrong if you derail that string as you draw it back if it's not in its groove. So let's check now again. It's going to be a much longer video than I was anticipating today, but we're going to do it right. All right, so we are almost there. I bet another half twist in those bottoms and we'll be there. We were at 79.9 on our draw weight. My draw board is also homemade, if you couldn't tell by its sweet custom appearance. It's just I believe it was from Harbor Freight or somewhere in China it came from, but it's a worm gear trailer winch. The worm gear is nice because it's infinitely adjustable forward and back, but there's enough friction in the system that just, stopping, it isn't going to unspool, but you have that mechanical advantage. It came with a hand crank. I obviously swapped it over to a 3/4 inch nut so I could use a drill, because sitting there cranking it by hand is very inefficient. It takes a long time to move it the distance that it needs to go. Okay. All right, like I said, we're going to put some more twists down here in those two. All right. Start on this side. When you're using the synonym press, you want to make sure you get it on there all the way, because if it were to slip off and you've got your fingers in a place, in one of those holes in the cams or something, and it slips off, you don't have all your strings on and stuff, that could rotate and relieve you of one of your digits pretty easily. So just be safe, take your time, pay attention to what you're doing. Don't be like me and make YouTube videos while you're doing it. Do as I say, not as I do. All right. Nice thing about this synonym press is it works on pretty much every bow. It's not approved for bows that go past parallel at rest. So like my old Carbon Defiant that I had, I used it on it, but use it at your own risk. I did have it slip off one time. I didn't have the bow pressed very much, but just a little bit, and those fingers did slip off those past parallel limbs. So just use at your own risk, but it does work. Having a bow vise such as this is handy for that. I'm just double checking, making sure I've got everything in its proper groove. Let's take a quick axle to axle measurement as well. We're at that kind of maybe 1/8 of an inch out of spec there. 3/16 maybe, but let's check what the draw length is, or I mean draw weight is. Alright, we hit 80.5. Now my top cam is hitting ever so slightly before my bottom cam, which if you can't get it perfect, that's my preference. So we'll leave it at that. We're going to quick shoot them through paper and make sure they're relatively tuned, because if they're not tuned, when we're taking those downrange velocity readings, if you're not in tune and that arrow is wobbling, it's going to have a little parachute effect, and it's not going to be as efficient as it could be downrange. All right. I'm going to shoot these through paper. I probably won't bring you guys along for that part. I'll probably just show you the results. This is getting kind of long-winded. Okay, so the right tears there, so these three are from the RX-9, and that's from my RX-3. Just one shot there. It might be just ever so slightly knock left. But as you can see here, these are significantly knock right. I played a little bit with the rest to see how much it was going to move. Didn't move hardly at all. So I think since I bought it used, I'm not sure if the previous owner had shimmed it a certain direction for the way he shoots. Or anything, so I'll probably have to go back to the dealer and have it shimmed. That is one of the downsides of the current Hoyts, is The cam shifting is not as DIY user-friendly as some of the new systems from many of the other manufacturers. I would expect to see Hoyt come out with something that allows you to shift the cam position without a press in the near future, but not this year, so I'm going to have to run to the local dealer, which isn't super local to me, to probably swap out shims. So today's video is getting cut a bit short. We're going to have to pick it back up at a later date. So here's where we're at now. I was looking on Hoyt's tuning chart for a knock right tear, and it says that those red shims, it is the most aggressive, and right now it is in the most aggressive in the wrong direction for me. So we're going to try to swap both the black shims and the red shims, and in order to do that with the tools that I have, that synonym press and things, I cannot, because the fingers hit on the cam itself. If I were to take that axle out, it would push that cam back, and I wouldn't be able to put the axle back in. So we're going to, as you can see, I have taken the string off. I've taped the cables to the posts that the quiver mounted on, and I've taped the string down to my workbench here to make sure that they don't untwist. And now we should be able to simply unscrew those bolts, pull the axle out, and swap the shims from one side to the other, and reassemble and try it out and see if that corrects us or if that moves us too far in the other direction. Then we'll need to get different width spacers from our dealer. Otherwise, here's where we're at. Okay, we were able to get those shims swapped on both ends. So in order to do so, I had to, with the tools that I have, so a portable press, and I had to take the string completely off, take the control cables off of the post, and then I taped them to the posts that the quiver attaches to prevent them from untwisting. Then I was able to relax the limbs, but in doing so, the block and tackle on the press didn't quite expand enough to release all the tension, so I had to do a little redneck engineering. I've got, where'd that go? Here it is. I've got this little slave pin that I use for putting pins in an AR-15, and I had to wedge that in this, what I believe is paracord or some sort of cordage there, so I could fish a little bit of slack through there. Thankfully, the limbs were almost completely relaxed, so there wasn't a ton of pressure in the system, so I was able to get that done. And I just guessed just right enough that when I was assembling it again, I was able to completely compress this inner block and tackle that allows you to compress the limbs So it was, you couldn't have pulled it another half an inch together. But that was just enough to get the string back on. So now we're going to check everything on the drawboard before we go and shoot it. And we're going to see if that fixed our giant right tear by swapping those shims. All we did was swap the big one. The thick shim was on the left. Now it is on the right on both ends. And we'll see if that shimmed it over to where it needs to be. Like I said, according to Hoyt's specs, that is the most aggressive in both directions, is with the red spacers and the black spacers. The gray spacers, I believe, are more neutral. So we'll see if we need to get those other spacers and try that out. But we're going to press this and see where we're at. So I didn't make any more adjustments. I just shot another one, and I knew my grip wasn't great on this one. I could feel the grip wasn't in the right spot, but I shot it anyways just to see if we were close. But I shot another one, and it looks like a pretty darn nice tear. So we are set at 13/16 on our center shot, and then I swapped those spacers around, and it looks like we've got a pretty perfect bullet hole there out of the RX-9. Again, that was the RX-3. Both are now shooting 80.5-ish pounds. Yeah, now we can kind of get some better apples to apples comparisons, get some distance shooting in, and have a little fun with it. Well, that's a wrap on today's video. I hope you guys found it interesting, comparing and contrasting how the older tuning on the Hoyts worked versus the newer tuning systems, and what you've got to do on something like the RX-9, RX-7, RX-8. As soon as they switched to the true dual cam versus their old cam and a half, the old cam and a half style bows, this was primarily how you tuned those, and got the timing right. And like I said, you typically yoke tuned those for left and right tears, where this you need to twist up and twist down your cables for your timing. And then we're shimming that cam left and right with those spacers for the newer style bows. And this goes across brands too. So if you're talking about the Matthews system with the top hats, any of the old bows where we had yokes and things like that, you could manipulate those yokes to change those left and right tears as well on those bows. So this isn't only for Hoyts, although that's the bows that we did work on today. And you can see that you can accomplish these things with pretty basic tools to be able to service your own equipment. Don't be afraid of it, but if you aren't confident, by all means, go utilize your local dealers. We need to support them as much as possible so that we do have a dealership network that we can rely on for our needs in the future. And so, obviously go support them as needed. But I will also be on the next video taking these bows outside like I plan to in this one. But we're going to get the lab radar out. We're going to take some velocity readings, not only out of the bow, but with the lab radar you're able to get downrange velocities as well, which is really cool. And that'll help me build out a accurate sight tape through Precision Cut Archery. They have a cool software program that allows you to kind of build that ballistic profile that we build out for our long-range precision rifles. It takes some measurements and different things, and it'll build you a similar like ballistic profile that will get you a more accurate sight tape than the ones that come from the factory with your sight. Those are kind of a one size fits all, but as you change your arrow weight and things like that, that does change how energy is retained, the number of fletchings on your arrow, all those different things equate to, drag and different drag coefficients and things that affect your downrange trajectory. And when you're getting out there to more extended distances, that's where the discrepancies become even greater. And I will be taking a scouting trip out to Montana this summer sometime to do a little bit of scouting. And I'm also going to take my lab radar and my bow with me. And I will shoot at elevation there as well and have a sight tape built while I'm out there to be able to know I'm good to go when I do get out there this fall and get to hunting. I'll know my sight tape is accurate. Going from Iowa elevation to Montana mountain elevation, it will change some, and I want to have as accurate of tape as possible. But if you guys like today's video, please give it a thumbs up. Comment with any questions or what you want to see. If there's anything between these two bows and the technology here that you want to see, let me know. A friend of mine, I think, is going to be updating. I think he's got the Halon 32, and I think he's going to be upgrading his to a Lift or a Lift X. And so we'll probably do a similar series with those two bows as well. So stay tuned for the Matthews portion. Comment, and subscribe if you would. And we'll see you guys on the next one. Thanks.